All right, so we are in Algebra 2, Lesson 1-3, Add and Subtract Polynomials. Today's date is Thursday, August 27th, 8/27, 2020. Our objective today is to do what with the quiet raised hand? Jade, go for it.
Combine like terms when adding and subtracting polynomials.
There it is. And this is very much an Algebra 1 lesson. Just making sure that we still have these basics down for Algebra 2. And I feel like we could combine this lesson, the next lesson, still be okay. But okay, let's just try this out. Like terms, what are they? They're terms that have the same what and the same what. Charles, yeah.
Variable and exponent.
Variable and exponent, there it is. Variable and same exponent. It's almost as if that kid just recently took Algebra 1. Yeah, so if you don't like the word variable, just think like same symbol, same letter, same exponent means same power. Let me give you a few examples and non-examples off to the side just to remind us. I cannot add x plus y. They are not the same variable. So that's this is the no category. This is the yes. I can add x plus x. Yes, that does equal 2x. I cannot add x plus x squared. Even though they are the same variable, now their exponent is not the same. This is x to the power of 1, it's hidden, and this is x to the power of 2. I cannot add those, but I can add x to the power of 3 plus x to the power of 3. That's 2x to the power of 3, right? All right, and then we are only allowed to add and subtract when they are like terms. What do we actually do with their numbers? And to give you a hint, if I have 2x plus 3x, that is equal to 5x. What am I actually adding and subtracting? I'm not doing the powers. I'm not doing the variables. That other thing. You can say, actually, there's a few things you can say in these fill in the blanks. Yeah, Wyatt?
Coefficient.
Coefficients, perfect, yeah. Mr. Godoy is sending all teachers a reminder that we're doing advisory today at 12:20. I thought we were doing advisory at 12:10. Uh-oh, now there's miscommunication. Yeah, so coefficients, kind of got cut up there, so I'm gonna say coefficients. Coefficients, and specifically coefficients of the like terms. I did not give enough room to write that. I apologize. We are going to be doing some harder things now that we're in Algebra 2. So last time we were always adding and subtracting like monomials, but or not even monomials, but like things that just had one variable. In the future, we're going to be like x, y squared, z to the power of 4th. You need to add that with something that has all three of those that match. So a little bit harder in the future. Just be ready for it. All right. So this is kind of what I was saying before. When you're adding or subtracting, the what never changes. And there's actually two things, I guess, that never really change. You can say either one of them. We'll get Charles a bit more so that you can just chill in the car. Yeah, go for it, Charles.
Adding and subtracting the exponent.
Exponent, yeah, that's the main thing. Yeah, you can do the next one too, if you want.
Is the next one variable? Or is it the sign?
Not quite. It's the one that Wyatt just set up above too, and I'm sure Wyatt's ready to repeat himself. I see him smiling. Yeah, go for it, Wyatt.
Just the coefficient.
Exactly. Yeah, and this is a really common mistake to even make in Algebra 2 too, is to actually accidentally add or subtract the exponent. For example, if I have x squared plus x squared, some people accidentally say this is x to the power of 4. No, don't do that. The exponent stays the same. I should get 2x to the power of 2. I know that there are some math teachers that go to extreme lengths. They're like, every time you do that, a kitten dies. Don't kill kittens. I don't know if those teachers actually go and get kittens or if they're just saying that. I don't know. Anyway, let's go to example number 1. We have that giant polynomial that is not simplified, and we need to add and subtract like terms to simplify it. And Josie, if you don't mind just leaving your camera on, I'd really appreciate it. What do I do for my adding and subtracting my like terms here? We'll go with Jose.
So you're gonna put 2x to the power 2 and then negative 4x to the power 2.
Yes, and I really like how you said that too. It's a negative 4x to the power 2. You're including the sign in front of it. Yeah, when you combine those two like terms, what do you get, Jose?
Negative 2x to the power 2.
Perfect. Do you want to continue on, or did you want to hand it off to someone else?
I can just hand it off to someone else.
Perfect. Okay, you want to do the rest, Sergio?
Then you add the y's variable, so it's 3 plus it's 5 y to the power 2.
There it is, and then we're done. Box it. Thank you, Sergio.
Do we have to put it in simplest form?
In the simplest form,
Like in the simplest, I mean like.
standard form,
like
you mean?
in the, yes, standard form.
You do, yeah. And then because these are both the same degree, this is degree 2 and degree 2. Normally standard form is degree like 4, then 3, then 2, then 1. If they're both the same degree, they're interchangeable. I typically do it alphabetically. So x comes before y, but you can do it in whatever you want. You're still correct either way. This is still standard form, and if I switch these two, they're still in standard form. But yeah, just the assumption that you should always be making, always write things in standard form. And as a tiny aside, something that's kind of important here is if I have x, y, z versus x squared, y squared, what is the degree of x, y, z? What is the degree of x squared, y squared? Like which one goes first in standard form? And we haven't ever talked about that. Does anyone have a guess on what the degree of x, y, z is? What the degree of x squared, y squared is? What is the degree of x, y, z? What is the degree of x squared, y squared? We'll go with Wyatt.
Is the degree of XYZ 1?
A good guess, but it's actually not. If it's not 1, what would you guess then?
0.
A good guess again, but not quite. I'm going to give it off to Charles.
It should be 3, correct?
3, yeah. You actually
because you multiply the variables, so then you add the exponent.
That's a good way of thinking about it, yeah. So all these exponents are a hidden 1, and then you're kind of just, since you're multiplying them all together, you're really adding the exponent. So this is a degree 3, and therefore, Charles, this x squared, y squared would be degree
4.
4, exactly, which means if I was writing this in standard form, the x squared, y squared would come first because it's a higher degree, and then I descend degrees. The next term I would write would be x, y, z. But it's not super important for this lesson, just as a heads up. All right, distribution, pretty straightforward. If I ever just say plus and then in parentheses, you're always kind of, I don't know, there's a hidden 1, I guess, here. There's a hidden 1 whenever you just have a plus or a minus. So always distribute that hidden number. Whenever you have a plus, you really don't have to worry about it. But I mean, if I just had to have a blanket rule to say, do this thing every single time, always put a 1 in front of it if there's no number, and then always distribute, and you'll always get the right answer. But I mean, you can start skipping steps here by saying, oh, if I'm distributing 1, it's the same exact thing. It's the equivalent of dropping parentheses. So let's go ahead and just show this really quickly. Let's go ahead and distribute the 1. Quiet raised hand. Who can distribute 1 times this quantity of c squared minus 7? I'm going to give it to someone brand new because this is kind of one of those easier questions. Make sure I'm building someone's confidence here, hopefully. What have you got? Someone new. Sorry, Jose. Yeah, Gunnar, go for it.
It makes it a positive 7, right?
Not quite. So a positive 1 times a negative 7 is a negative. So it's still negative 7. What about positive 1 times c squared?
Wouldn't it not change anything?
It wouldn't. Yeah, so you just rewrite c squared. Exactly. Yeah. So having a plus in front of the parentheses is the equivalent of just getting rid of the parentheses. What about this one? What about distributing a -1 into c squared minus 7? You don't have to do this one, Gunnar. If you,
into
you can if you want, though. Okay. I saw a hand. I don't know who it belongs to. I just see a painting on your wall. I see the very tip of your hair. Now your hair, is that Andres?
Yeah, that's me.
Andres, just point your camera down, man.
Okay,
Let me see
wait.
who it is.
Can I answer this one first?
Yeah, you can, yeah.
Okay, so it's going to be -c squared plus 7.
Plus
Right.
7, exactly. Yeah, it switched both the signs. Precisely, yep. All right, and then we have just two more examples, and then we're done. There's no backside of this. So there they are. All right, adding and subtracting like terms, final problems, the hardest things I can really throw at you today. What to do? Lots of people are writing this down. What is the first step that I do? I'm going to call on someone I haven't called on before, which means it might be a cold call. Let's go with Fern. Haven't heard from you in a bit.
You find the same variables, or
Yeah, like terms.
yeah, like
Yeah.
terms.
What are the like terms?
It's a b and -4b.
Perfect. I like how you included the sign in front of it.
-3a squared and 2a squared.
Perfect, yeah. And the reason we don't have to worry about the plus just for everyone else is, again, just like we had up here, the plus just means we kind of ignore it and we just drop the parentheses. Perfect. Did you want to continue, Fern, or do you want to give it off to someone else?
I can give it off.
All right, cool. Okay, I'm looking for another person who's got this. I want to try to get everyone in, so I'm going to call in someone new. I'm just going to cold call in people then. Yeah, Cohen, go for it. So you can either combine like terms for the b and the -4b, add those two, or you can add the -3a squared and 2a squared, whatever you prefer.
-4b and b, wouldn't that just be -3b?
There it is, -3b. Thank you. Cool. And then I'll call in someone else. Who have I not heard from? Jessica, go for it.
So am I gonna simplify or add like terms for 2a squared?
Yeah, the 2a squared and -3a squared, those add up to what?
Is it -1a squared?
-1a squared, yeah. And that actually reduces to just -a squared. Yeah, very nice. -1a squared and -a squared are the same numerically. This is just slightly more simplified. Yeah, thank you. All right, I've almost got everyone. I think I need to call on 2 more people. Is Jenny not here anymore? No, she is. Where is she? She's going to be called eventually. So with Josie too. In this last example, I need to get those 2. Okay. I need someone to identify like terms, either Jenny or Josie. Who's it going to be? Jenny, go for it.
3m squared and 4m squared.
Perfect.
Oh, do I keep going?
If you don't mind, if you can either identify all the like terms, or then if you don't want to do that, you can just add these 2 together. But you have to be careful about adding them because we have this negative here.
I'll just continue saying and
Yeah, and let's use the minus in front of it. So -n cubed and
2n cubed.
Perfect. And what are the other ones?
6, positive 6.
Yep.
And negative 3.
Negative 3. Okay, thank you. Jenny has figured out what all the like terms are. I need Josie, you need to somehow deal with this negative. And it's something that I just went over right up here. When we had a negative in front of it, like we have down here, we distribute it into each of the terms in here. So how are we going to distribute this negative? Can you tell me what to write down here?
I'm sorry, Mr. Sindel. I'm really distracted right now.
Okay. Would it be better if I help you along, or do you just not want to respond? I'll help you. I'll help you out. I'll help you out. Okay, so I'm multiplying -1 times 4m squared. Essentially, I'm just switching the sign. It was a positive 4m squared. Now it's a
negative
4m
All
squared.
right,
Yeah, keep
Mr.
going.
Sindel, I'll be back.
All right, thanks, Charles. Keep going, Josie. I had a positive 2n cubed. What do I have now?
negative
2n cubed. Keep going.
positive.
There it is. Thank you. All right, and then I'm just going to call in random people now, however many times you want to participate. Wyatt, go for it.
You want me to simplify one of them?
Yeah, I mean, you can simplify all of them if you want. We're basically done.
Okay. So the final answer that I got was -m squared minus 3n cubed plus 9.
There it is, +9. And then I'll go ahead and box my final answer. Again, if it helps, you can kind of cross out this one and so you don't use it. We're using the Josie's new -4m squared minus 2n cubed plus 3. Yeah, there's our final answer. You're going to be doing the same type of stuff for your homework tonight. I already assigned the homework for tomorrow night as well. That's due on Monday. So, I mean, if you want to get ahead, you can do that. I think it's pretty straightforward, I would think, but maybe I'm wrong. But yeah, that concludes the lesson. I'll go ahead and stop there.